our first speaker is Allison Pease. She works in natural resource management, and she'll be talking about the impacts of environmental change on the functional structure of stream fish assemblages. And then the second speaker is Robert Pearl of architecture, and he's going to be talking about buildings and sustainability. And then our third speaker is Brett Hauk from the Department of Sociology, Anthropology, and Social Work. And then he'll be speaking about the ancient Maya and about culture, climate, and collapse. So that'll be very exciting. So without further ado, Allison, you can come up here.
Mouse here?
Yep.
All right, so thanks for the introduction and thanks for the invitation. I'll talk broadly about environmental change, including impacts that we might expect in habitat based on climate change, but other changes that we expect based on anthropogenic influences as well. We know that stream fish assemblages are expected to be impacted by a diversity of environmental changes, and we have pretty concrete expectations about changes in diversity of fishes as a result of things like flow alteration, things like building of dams, overpumping of groundwater, things like that. Urbanization impacts, we know that that's going to have an effect on fish diversity. Non-native species invasion, another kind of environmental change of the biotic flavor. And then we expect a lot of habitat changes with climate change to affect diversity of fish assemblages. And one of the questions that I'm really interested in is, beyond changes in what species are expected to be where, abundance or presence of species A, B, and C as the winners or losers with climate change or some of these other impacts, how is the functional structure of stream assemblages expected to change? That is, particular functional groups like fishes that specialize on particular food items or habitat types. Are we expecting certain patterns there that might translate across geographic boundaries? If we know that trout species X is vulnerable, that's really important, but how does that translate out of its geographic zone? If we can focus on functional traits and functional groups, maybe we can come up with patterns and predictions that translate across geographic boundaries. So functional traits can be really useful indicators of environmental change. Some of the kinds of questions that I like to ask with my research include, how does composition of a local ecological community of fishes in terms of trophic groups, life history strategy, reproductive guilds, habitat guilds change along with environmental gradients, particularly environmental gradients that we know are affected by anthropogenic influences? Which of these relationships tend to be consistent across taxa and across biogeographic boundaries that might be the most useful for our predictions, especially when we're predicting what might happen as a result of climate change? And a really promising area of research is not only to determine which traits respond to changes in the environment, but which of those traits that do respond to the environment, which of those traits are most likely to have a profound impact on ecosystem processes. For fish, some of our guesses in terms of what might be a good response and effect, combination of response and effect trait, might be changes in body size or changes in trophic composition. We know those are sensitive to environmental change, and we know those have pretty important implications for things like nutrient cycling, food web structure, and other ecosystem characteristics. So one of the ways that I particularly like to look at these kinds of questions is by looking at changes, and how changes in habitat with environmental change and changes in community structure are reflected in changes in the overall food web, the local food web in streams and rivers. And so here I might ask questions like, how changes in the environment affect the sources of carbon production that support a food web? And as it turns out, we can see some pretty big changes, especially with things like land use change. Riparian clearing can, for example, have a pretty profound influence on what kind of sources of carbon are available at the very base of that food chain, with cascading effects throughout, which we can document using tools like stable isotope analysis. I also am interested in looking at how fragmentation, flow alteration might affect energy transfer as we would expect it, theoretically going down a river continuum from upstream to downstream. How overall measures of food web diversity, like food chain length, are affected by environmental change, and how non-native species, something we expect to see more of in many cases with climate change, are affecting local food web structure.
Where would that particular, is that a theoretical model or is that a reality?
This is real data collected from a river system in Belize, where we were looking from upstream to downstream on a river continuum and measuring differences in average carbon and nitrogen isotopes for the fish community. And we did find that in some cases, in this case, this is a highly impacted site due to banana agriculture. We saw a deviation from our expectations of what should be happening from upstream to downstream on a river continuum. Taking this a little bit further, there are other ecosystem function questions that are clearly related to functional traits of fishes that we expect to change with environmental change. We might expect to see changes in nutrient cycling with changes in trophic structure, changes in body size, as I mentioned before. And I'm really interested in where these changes in ecosystem processes have implication for changes in important ecosystem services like fisheries. A lot of my research takes place in southern Mexico, where I'm working with small scale and artisanal fisheries and looking at how changes in rivers affect the economic value of fishes that are abundant or gone in particular streams. For example, we find that flow alteration tends to favor lower valued non-native species and increases the likelihood of extirpation for species that are migratory and are highly valued in local markets. So with climate change in particular, we expect that within populations, within species, we would find changes in growth rates, timing of reproduction, as well as characteristics like fecundity as a result of climate change, changes in temperature, as well as changes in flow regime. We expect some species to be winners and losers, some functional groups to be winners and losers. The functional groups that we're most concerned about are specialists, habitat specialists, thermal specialists, cold water species like our native trout, which we're already seeing the negative results of climate change in the western United States, for example. We expect migratory species, another important functional group that is negatively impacted by changes we expect with a changing climate. We expect winners to include our generalist tolerant species that can handle a broad range of temperatures, a broad range of habitat conditions, and can rely on a broad base of resources. This includes non-native invasive species for the most part, and non-natives are interesting in terms of our expectations for climate change because they're expected to be boosted, particularly warm water and tropical non-natives, through a couple of different ways. We expect to have increased pathways of introduction because we're expecting an increase in warm water aquaculture, which is one of the most important vectors of non-native fishes in the United States and elsewhere. And we also expect increased likelihood of establishment once they're introduced with warmer winter conditions. A lot of what keeps some of these species from being successfully established in many parts is a winter that's too cold for something like a tilapia or a red-bellied piranha or something like that. But as winters are warmer, we expect greater success for establishment. We may see range shifts within species as well. This is not going to be possible in some places due to fragmentation with impoundments. It's also tough in some areas like the Great Plains, for example, where we have rivers flowing east to west and not north to south, so there's fewer opportunities to move up for cooler temperatures. And along with a lot of these changes, we expect changes in species interactions. So that gets back to our food web structure. We expect with changes in body size, changes in phenology, we may have new matches or new mismatches in terms of predator-prey. As we have greater successful establishment of non-native species, we may have novel trophic interactions. So changes in interactions are expected to be a major feature in stream assemblages as a result of climate change. So some of my previous research involve documenting these trait-environment relationships. How do changes in the environment or environmental gradients result in changes in functional diversity of fish and local stream assemblages? And what I have found in my research in Texas, for example, is that particular traits related to habitat use, body shape particularly, is related to presence or absence of riffles or pools, which is something that we expect to change in the habitat as a result of flow regime change, or drying rivers and streams with climate change, for example. And along with habitat variables related to land use change, like the amount of intact riparian vegetation, we find changes in the trophic structure of the community, with greater trophic diversity and habitats with a more intact landscape, more herbivore, detritus-feeding fishes, along with generalists and piscivores, insectivores, in a habitat with a nice intact riparian zone. So morphological diversity, trophic diversity expected to be favored in habitats less impacted by flow regime change and land use change. My current research, a great deal of my local current research is in the Pecos River in West Texas and East New Mexico, where we have no shortage of environmental changes to examine, including flow alteration, salinization, which goes along with the decrease in discharge that we have in the river as we have less fresh water to flush out some of this naturally occurring salt. The concentration of salt is going up ever higher, approaching near ocean water conditions in some parts of the river. Non-native species, including fish, but also things like salt cedar that may be impacting the food web structure. And of course, this is a big area for oil and gas development, and there's some urbanization. Some preliminary results from the research in my lab, this is from my student Jessica East's thesis research, shows that we're seeing some interesting patterns here. This is within Texas, the lower Pecos River, and the Edwards Plateau further down south, and the Permian Basin in southern New Mexico right below Red Bluff Dam. Where this is a low part of the river, we would expect a broad diversity of carbon sources supporting food webs and a nice spread across the nitrogen axis, reflecting a nice long food chain. We do see that in the Edwards Plateau, where we have a mixture of riparian and algal and stream sources supporting the fish food web, whereas in the Permian Basin, where we have the worst environmental change impacts, we're seeing almost complete reliance on in-stream production and a shortened, less diverse food web. So this gives us some clues as to what may be happening with some of the environmental changes, like decreased discharge and salinization that we might expect in streams as a result of climate change. Some future questions that I'm interested in asking include things like how tributaries might influence some of these changes and what role they might play in terms of a source and a refuge for diversity of functional traits and as a subsidy for food resources, and how flexible some of these populations are in terms of their functional traits as a response to these environmental changes. All right, thanks. Yes.
This past week, we had a massive flood of South Carolina. Some people said, television commentators, I don't think know their geography, said all of South Carolina was flooded. Well, there's hill country with plateau, but in any case, the lowlands were certainly flooded. Some 10 years ago, we had Hurricane Katrina. Is there now some modeling going on that may give us some ability to develop models of stream changes and diversity in species because of these huge movements of water that are bound to bring in invasive species?
Opening in new dispersal pathways. Yeah, there is a great deal of sophisticated flow modeling that models changes in flow with big precipitation events and with changes in flow we would expect with climate change. Linking that to dispersal pathways for non-natives is really fascinating. I'm not sure what the current state of the art is for that, however.
Do you know how much Texas has lost in terms of fish diversity? Do you have an idea, at least for this area?
Yeah, I don't know. Do you know, Tim? You have a number?
I think it's 35 species that have been extirpated or driven to extinction in the state. That's the number I want to,
Over how many years, Tim?
probably the last 200 years or so.
Okay.
Out of how many?
We have what?
Fresh waters about
200 something?
270,
That's a
280.
big number.
That's
Yeah, it's a
number.
big percentage. Mhm.
Wow.
Yeah.
And these are, these are a lot of our fish that need broad spaces to migrate, so
Right.
things,
Or extremely localized.
or
It's the
extremely
localized.
endemic spring species.
So I'm just thinking about, Jorge, you would know too, Dave Schmithy wrote that book on the mammals of Texas and looking at what happened 50, 60 years ago to what's happening now in terms of mammal distribution across the state and how many small mammals have gone extinct and whatnot. I'm just wondering how fish, work compared to that.
Yeah, it's probably pretty similar in terms of percentages, I would bet.
Right. There's a really good website out there UT has done, the Fishes of Texas, where you can actually look at distributions, museum collections anyways, through decades and stuff, and see how that's changed. They've documented some changes.
How many have we gained?
That's a good question. We're gaining more and more, but
Gained or established? I mean,
yeah.
Yeah, right, sure.
We're not as bad as some places. I mean, you go west of the Colorado River in Arizona, for example, where the communities are dominated by non-natives. We're not quite there, but yeah, we have a lot of non-natives in our reservoirs, and interestingly, in the system where I'm working here, we've got coastal baitfish that are really loving their new salty home in the inland saline river of the Pecos and part of the upper Brazos as well.
One more question? All right, thank you very much.
All right.